And in 1968, string theory was found by accident. Two postdocs, Veneziano and Suzuki, were looking through a math book, and came up with the beta function, which seemed to describe the collision of pi mesons. Why should a math book describe the intricacies of the collision of subatomic particles? Years later, we found out that it was a vibrating string that made all these things possible. If you were to summarize all physical knowledge, I mean everything, the whole shooting match, lasers, microwaves, gases, liquids, everything into two great theories, they would be the theory of relativity, which gives us black holes and big bangs, the theory of the big, and then we have the theory of the small, that is atomic physics, which gives us laser beams, transistors, the internet. All the electronic wonders that we see around us are consequences of this quantum theory. The irony is, and this is the fundamental problem rocking all of physics, these two theories don't like each other. The theory of the big and the theory of the small hate each other. Every time you try to combine them, it's like a shotgun marriage. It never works. And this is where string theory comes in. String theory is the only theory in all the decades we've worked on this that actually merge these two into a single theory. It's amazing. They just like zip, form one coherent framework. Now, some people say, well, maybe I don't like string theory. Maybe I want another theory. Well, hey, there is none. This is the only game in town. No other theory has been able to combine the theory of the big, relativity, with the theory of the small, the quantum theory, into a single theory. This is the only game in town. So I tell young people, if you don't like it, create your own theory.
Now let's be clear about this. Technology is a sword. It's a double-edged sword. One side can cut against disease, ignorance, and poverty, and can really give us a type 1 civilization. However, there's a second side of the sword. The second side of the sword could also cut against us unless we are educated and we understand the power of this technology. There's some people, by the way, who instinctively do not want this march to a type 1 civilization. A type 1 civilization is tolerant, multicultural, because it is planetary, and it is progressive and scientific. The people who don't like it are the terrorists. That's why terrorism is so appealing to people, because for some people, they don't like modernism. Modernism means tolerance, multicultural, other cultures interacting with other cultures. And, hey, that's a type 1 civilization. And that's where we are headed.
Do you believe in a God?
I would believe in the God of Einstein. Einstein was asked this question many times. And he said, look, there are two kinds of God. So let's be clear about this. The first God is the personal God. The God that answers prayers, the God of Isaac, Moses, Jacob, the God that parts the sea and walks on water. The God that answers prayers, the personal God. Einstein said that no, he believed in this other God. The God of Spinoza and Leibniz, the God of reason, the God of beauty, elegance, simplicity. That it's amazing that the laws of science are very simple, very elegant, very mathematical, and it couldn't have been an accident. He said to himself that, look, we are like children entering this huge library, this cavernous library. All we can do is take the first book, open up and read the first page of this first book of this cavernous library. And so he said that he believed in the God of order, the God of simplicity and harmony. I would say, well, yeah, maybe God is not necessary to create a Big Bang, but then who created string theory? Where did the theory come from? Where did the mathematics come from? And at that point, physicists stop. Okay? So we can go before the Big Bang. We're not embarrassed about that anymore. But then the question is, where did the law come from? Who is the lawgiver? God is supposed to be the lawgiver. If the law is string theory, where did that theory come from? And I think even Stephen Hawking would say, I don't know.
When Star Wars came out, people loved the movie, but the critics said, Death Stars? Nah, you cannot destroy a planet. A planet is too big to destroy, they said. Well, that's not true. First of all, there's no upper limit to the power of a hydrogen bomb or a laser. You can make them arbitrarily powerful to blow up an entire planet. How do I know this? I know this because when I was in high school, my mentor was Edward Teller, father of the hydrogen bomb. And he even offered me a job designing hydrogen warheads. I turned him down because I wanted to work on something even bigger than a nuclear detonation. And that was the Big Bang. So let's talk about this. Gamma ray bursters are one way to destroy an entire planet, like in Star Wars. They are the largest source of energy. They're black holes, second only to the Big Bang. And unfortunately, recently, we found one pointing directly at us. This is WR104. You're staring down the gun barrel of a star that will blow up, and when it blows up, its beam is pointed at us. This is WR104. This is the Death Star. Any empire could take a dying star, point it in a certain direction, aim it, and then fire it at Alderaan. Now, to be fair, we don't know whether this star has already blown up. Maybe it's already blown up. It's 8,000 light years away. Maybe 8,000 years ago it already blew up, and we're just too stupid to know it. Or it may be a dud. We don't know. We know very little about black holes. All we know is we are staring down the gun barrel of a potential exploding star. Now, on the internet, just last week, they did a recalibration of this. This thing may just miss the Earth. The latest evidence shows that the beam that comes out of this Death Star may just miss the Earth.
Hyperspace is dimensions beyond the visible universe. Everybody knows the universe is expanding. But then the question is, what is the universe expanding into? The universe, we think, is expanding into another dimension. We think our balloon is expanding into 11-dimensional hyperspace. Now, get your head around that. We're way beyond the fourth dimension. We think that the instant of creation was basically a quantum fluctuation in 11-dimensional hyperspace.
Why 11?
It turns out if you construct a universe of 13, 15 dimensions, the universe is mathematically unstable. The mathematics shows that these universes topple down to 11 dimensions. You can't escape it. String theory is the only theory which selects its own dimensionality. You can write Newton's laws in any dimension you want. You can write Einstein's equation in any dimension you want. But why do we exist in 3 dimensions? For the first time in history, we now have a theory which actually selects its own dimensionality, because these other dimensions are unstable. And then 11 dimensions, we think, ultimately collapses down to the 3-dimensional universe that we see and touch.
What's the 4th dimension?
Well, Einstein said the 4th dimension is time. So if you want to meet somebody in Times Square, you say, meet me on 42nd Street, 5th Avenue, 10th floor at noontime. So it takes 4 numbers to specify lunch in Manhattan. But we now believe there could be other dimensions, perhaps as many as 11 dimensions. And we hope to test these ideas with the Large Hadron Collider.
Now let's go into outer space. Everybody loves a starship. Some people say that flying saucers are impossible because the distances between 2 stars is too great for any UFO. Yet NASA is already looking into the possibility of building a starship. I know this because I had to review some proposals for NASA. So let's look at some of them. One is to build a sail, like a sailboat, in outer space. You put a laser beam on the moon. You shoot a laser beam to the sail. The sail is pushed by laser beam pressure, and you can reach near 50% the speed of light this way. This is one of the serious contenders to build the first starship. Another possibility is nanobots, microscopic little things that are then sent to moons. Now, if you saw the movie 2001, you realize that Arthur C. Clarke, who just passed away, was a visionary. He realized that if you are an advanced civilization, you're not going to send Captain Kirk on a starship. You're going to send a robot. This is a robot. The robot lands on the Earth and creates a copy of itself. millions of copies of itself, and they shoot out, land on other planets, other moons, and they make a copy of themselves, more factories. Starting with one robot, you get 1,000. Starting with 1,000 robots, you get 1,000,000. Then 1,000,000,000. And pretty soon you have a sphere of robots expanding near the speed of light, colonizing all the moons, colonizing all the planets. That is the basis of the movie 2001. The movie 2001 is the most realistic encounter with extraterrestrial civilizations. If we ever meet an alien, probably it'll be a robot, a self-replicating robot left over from a passing civilization. This is my favorite, the ramjet fusion engine. It looks like an ice cream cone. It scoops hydrogen in the forward direction and burns it for fuel. This starship could last forever, because hydrogen is everywhere. This is my favorite proposal for a starship.
It goes back to my childhood. When I was 8 years old, everyone was talking about the fact that a great scientist had just died. And they showed a picture of his desk with his book, unfinished manuscript. And to me, this was incredible. How could the greatest scientist of our time not finish this problem? Well, it was Einstein's unified field theory. But at that time, I also was doing something else. I was watching television. Every Saturday morning, I watched the Flash Gordon series on TV with Buster Crabbe. I mean, I was floored. For the first time, I saw evidence of alien civilization, starships, ray guns, city in the sky, anti-gravity, all the things that I never even thought of before. And then I began to realize something. I began to realize, first of all, I didn't have muscles and blonde hair. I wasn't an Olympic swimmer like Buster Crabbe. But it was the scientist who made everything work. So it was Dr. Zarkov with his starship, with his city in the sky, with his ray guns. Without science, there's no Flash Gordon. And so I said to myself, well, these are two passions of my life. One is to understand physics. The other is to understand the future and science fiction. Maybe they are actually the same thing. The two passions of my life are really the same. Because to understand time travel, to understand dimensional gateways, to understand antimatter, the fourth dimension, you need the most advanced physics there is, which is string theory. And so I thought to myself, wow, I can merge the two great loves of my life. So I'll admit it, I'm a Trekkie. I've watched all the Star Trek movies, all the Star Wars movies. I love this stuff, okay, because it forces you to open your imagination. Now, to be fair, sometimes I kind of like grit my teeth watching these science fiction movies because I say to myself, well, that's not right. No, that's not right. No, that's wrong. That's not right. But then I say to myself, hey, relax. Enjoy the show. Go with the flow and have some fun.